Guys, today we're going to talk about proportional versus non-proportional relationships, and we actually have two I can statements, which I know is unusual for us in a video, but they go hand in hand. So the first one is I can determine if two quantities are proportional from a table, and the second is I can identify the constant of proportionality from a table. And the way that these work hand in hand is that if a relationship is proportional, it will have a constant of proportionality. If it is not, it won't have a constant of proportionality, or COP, as we'll call it. So basically, you're looking to see, is there a COP? If so, then yes, it is proportional. If not, then no, it is not. So let's look at what these terms mean. First, proportional relationships are those that have two quantities that vary directly with each other. And what that means is if I use this equation, where y is your dependent variable and x is your independent variable, k would be your constant of proportionality. So if you, like I said, if there is a k, if every x and y value in your table work together to create the same k, which means you have a constant of proportionality, then you can say, yes, these two quantities represent a proportional relationship. There is going to be one exception where 0 is involved for your independent variable, but we'll talk more about that in our next set of quadrants. So let's talk about what constant of proportionality is. It is the value of the ratio of the proportional quantities. So again, let's go back to that original equation I gave you, y equals kx. So the way we find the constant of proportionality is y divided by x, and here's why. I have this equation. When you have a table, you're going to have x values and y values in that table, your independent and dependent variables. So if I have this equation, k and x, I'll notice, are being multiplied, which means in order to solve it, I need to divide to get k by itself. I'm going to divide both sides by x, and I get y over x equals k, which is my constant of proportionality. So in order to find k, I need to take every y value and divide it by the corresponding x value. So let's look at an example of this. Here I have two tables, and the table on the left represents a proportional relationship, where the table on the right represents a non-proportional relationship. Okay, again, we're going to talk more in the next section about 0 and how that plays in, so let's ignore it for now. Now, in order for the left side to be a proportional relationship, I need to find k. Remember, k is where I take all my y values and I divide them by my x values. And I need to get the same thing. They need to be equivalent ratios. Time is always going to be independent because we can't stop time. Y is going to be my dependent variable. That is determined based on how much time has passed, my distance in this case. So here we go. So I need to take my y value of 6 and divide it by my y value of 2, which gives me 3. 3, if I get 3 for every single ratio in this table, then I can say, yes, this is a proportional relationship. Let's try the next one. 12 over 4 is 3. 18 over 6 is 3. So since all of these ratios are equivalent, and I can find a constant of proportionality, which is 3, I can say, yes, this table on the left represents a proportional relationship. Now let's look at the one on the right. Again, I'm going to ignore 0. Let's see if all of these ratios are equivalent. So I'm going to take again, time is my x, distance is my y. 10 divided by 2 is 5. Not 4. 16 divided by 4 is 4. I can stop right here. I did not get the same constant of proportionality, 10 over 2 is not equal to 16 over 4. So since my ratios are not equivalent, I cannot find a constant of proportionality. I do not have a proportional relationship. I don't even need to check 22 over 6 because if one doesn't work, the whole thing doesn't work. So let's look at some more examples. And for this, you're going to need your companion guide, your companion worksheet, which was linked in the unit guide and is also, you have a copy in your packet. Okay, so here we go. We've got our companion worksheet that goes along with this video, and let's just look at the directions first of all. Determine whether the set of numbers in each table is proportional. If the relationship is proportional, identify the constant of proportionality. Remember, that's going to be my y divided by my x. And then explain your reasoning. So, looking at number 1, the top value is going to be my x, the bottom value is going to be my y. The number of socks I choose to buy or make or whatever will determine the cost of those socks, okay? So here we go. Y over x. 2 over 1 is 2. Y over x. 4 over 2 is 2. Looking good so far. Y over x. 6 over 3 is 2. So far, so good. But here's where we go, uh-oh, look what's going on here. Y over x, 6 over 4 is 1 2/4 or 1 1/2. It is not the same as my first 3 ratios. Therefore, this is not proportional because all ratios are not equivalent. All ratios must be equivalent. Okay? So why don't you go ahead, pause the video, and see if you can work these out. We'll check them, but go ahead, pause the video, do numbers 2 through 7, and then press play. We'll check your work. Okay, let's check your work. Go ahead and look at my answers, compare them to yours. Make sure for 2, 3, and 4 that you have explained your reasoning. Just a simple sentence, why they are or are not. For 5, 6, and 7, you did not need to explain, but if it was proportional, you still need to give the COP, okay? So pause, check your work, then press play. I'll show you number 7. Okay, let's look at number 7. For this one, there were 3 things that you needed to do for this problem. So big mistake I usually see in this unit is that students don't give all answers to all the questions. So find the constant of proportionality. Every day is going to be the same amount, so the rate would be 240 miles per day. Y equals kx. Remember that equation? I don't know y or x, but I do know k. And then I'm given x, which is 4. So 240 times 4 is 960 miles. Don't forget your units. We are now done with this video. You can go back and watch any portion of it as many times as you need to, or the whole thing, but don't forget to WSQ in your notes.